Okay, this is an Amiga 500. It's not my normal one. This is fresh off the shelf. It is absolutely filthy. I do apologize for that. But what we're going to do is have a look at the DENISE in this A500, and we're going to go through some of the signals. We're going to go down this side. We don't really need to go down both sides, and see what they look like in a good working system. I'll show you that this is working because we can have a quick look and see. Yeah, workbench screen. So we're just going to go down and have a look at some of the signals on a working machine, and we're going to look at the chip data bus, which is just shared between chip RAM and the custom chips, and this is where I think the problem is. So let's just start here with DRD7, and there you can see that's a good clean data bus signal. 8, 9, 10, 11, 12, 13, 14, 15. And then we'll work our way up from the other side. So this is blue signals. That's 1, 2, 3. And you can see we've got stuff going on there. This is our green signals. You'll remember we saw that these were absolutely flatlined. Here's our blanking pulse. Here's our pixel SW signal. And now we've got our clocks. So that is what a working DENISE looks like, and the working chip bus. So we're back once again looking at the CDTV. Now, as we left it, the machine is basically totally blank. There is no video output at all, not even a black screen. And I think the problem is somewhere on the chip bus. Now, there's two data buses in this machine. There's one that goes to the CPU and some of the peripherals, the CIAs and so on. That's like the main system data bus. There's also a second data bus that goes through the custom chips and the chip RAM, and for the sake of argument I'm going to call that the chip data bus. I think that the problem is with that chip data bus, and I'm going to show you very briefly what that looks like on this machine, and then I'll show you what it also looks like on a working Amiga. So here's the pinout of the DENISE. This is the DENISE chip here, and we're going to be looking at that. So I'm powering it up, and then we're just going to run down this side of the chip and see what the signals are looking like. So the signals at this top end of the chip are basically the chip data bus. So let's just use the shield for an earth, and you can see this is basically sort of tri-stated, I guess. I'm not sure if it's a tri-state bus or not, but it's at roughly 1 volt, just sitting there doing nothing. And that goes for the entire bus. And then if we come back and look down at this other end, we can look at the color signals. That's blue. That's green. Now this is the blank signal. which we do seem to have, and also pixel swir, and now we're seeing the clocks, which I think come from the AGNUS. So we're basically not getting any data signals from the chip bus. Now these buffers here, the LS244 and the 373, these are what govern the interface between the main CPU bus and the chip bus. And we've already taken those out and replaced those. I'm pretty confident that those are okay. So the sort of elephant in the room is actually this AGNUS affair with the 2 meg memory on it and so on. Now it is possible that if we take this out, I'm going to turn this off now. If we take this out, we can put a PLC socket in to the header and then put an original AGNUS, which I can take out of my A500, into here, and this is going to eliminate or otherwise this board from the equation. Before I do that, let me put my strappy on. So this is quite a stiff thing to get out, right? But out it is. And then this would go in, pin 1 is that way, so that will go in like this. But the problem here is that this is really loose and floppy, and it's not going to make a good connection because we've tried that before, and that's not a good connection. What we really need to do is use some of these turned pin headers, which will fit quite nicely onto this, and that will be quite secure. But the problem that we'll then have is that this won't actually go onto these pins, because these 10 pins are too small for these chunky square connectors. What I think we're going to do is take these off and put some of these on, and then we're going to have to do something else with this. I don't really want to take this connector off because that is going to be a real pain in the proverbial backside. So what I'm proposing is that we use or transfer this to another board, and I've got one of those on order from our sponsor PCB Way, but it's a different layout, so it displaces the top socket from the bottom socket, so it extends them and it puts these other chips onto the back, kind of like this. We can transplant these chips from here onto the new board. So let's strip this down yet again and take this off and build a new socket and try the original AGNUS and see if suddenly everything works. If suddenly everything works, then we know that this was the problem. If it doesn't work, then we're no worse off. It's January and winter is kicking in. Thanks to our sponsor PCB Way, you can get 5 printed circuit boards for just $5. You can get them in a variety of colours. These are blue ones, these are yellow ones, these are purple ones. All you need to do is upload the Gerber files, pick your colours, any other finishes that you want, and a week or so later you will get a package back with your PCBs in it. You don't have to design your own boards. There are hundreds of ready-made designs that you can choose from on their shared project site. Check them out, www.pcbway.com. I'm just going to try flooding this with flux and then wicking it off with braid, see how that gets us. So let's just try down one side. Okay, that came off, but I don't know if you can see it. Unfortunately, we managed to rip a trace. It's this one here. That pin there. So we're going to have to bodge that. So I don't think we're going to be able to put that back into the hole, but that we can follow that through and it disappears underneath that capacitor C109 to a veer to the other side of the board. So this is, I think, a 4-layer board, which makes it kind of tricky to desolder in any case. So we're going to have to be a lot more careful with these other 3 connectors. I think I'm going to use hot air on those. So this is the broken wire, and this is the hole that it goes in. Gooey flux in there. And that's where I need to cut the wire. Now, if you are a skilled trace repairer, you could probably lay a new trace along this sort of channel and do it that way, but I'm going to do it on the back because I think that's going to be more successful. So I've got a brand new knife, very sharp, good pointed blade, and what I'm going to do is just score it along there. And that's come off. It has scraped the other one slightly, but I think that's going to be okay. We can put a daub of stuff on there to protect it. Just curious what this is. Okay, that appears to be missing solder mask. All right. Okay, I think we'll put the headers on. So what I've done here is I've pre-cut these header strips to match the pin layout, and I'm just going to push them on so that they are already in place, and then when we put them into the board, that is going to fit properly. At least that is the theory. Okay, that's in. It's a real faff. But we know that the socket has got all the pins in it and it fits, and so when we put this into the main board, there we go. Now there's an arrow in there that indicates pin 1. So assuming this goes in here and it actually goes in, then we know it's going to fit. There we go, that is in. So now all we need to do is solder that. I've marked the pin that we need to do the trace, and I should mark where we're going to take it to, and it is C109, which is that rear there. So we need to run a wire that goes from there to there. Right, fan's going to be on. Opposite corners doesn't really make such a big difference on this connector because of course it's all individual pin headers, but we will do corners. Okay, that's all soldered. So now I've cut a piece of wire to a good length. In fact, far too long. And what we're going to do is lay it down on the board, stick it down with some Captain tape, sorry. It's already been tinned at this end. Like that. We can solder that. Now that end is firmly attached. We can just bend the wire round. Tape it down. And before we go too far, what we're going to do is just scrape some solder mask off this little veer. I'm just going to do that with the magnifier. Ever so gently. Okay, we can tin that. Right, I'm going to tin the end of this wire, which should take the heat shrink, the sleeving back. There we go. We can put another little strip of Kapton tape over that. So there we go, a nice neat bodge. So let's just check the connection. I've marked pin 15 on the back of Gary. That's there. And this is pin 20 on here. We're going from here to... There we are, we have a good connection. Now we could replace the Kapton tape with hot glue if we want to, just to hold it down a little bit more permanently. So this is the new socket, and we can put in here the original AGNUS and see if it works, or at least my original AGNUS off my A500. Let's hook it up and see if we are getting anywhere. I've got a feeling that that is going to be kind of high. We may well not get the lid on at the end of the day, but we shall see. Right, the board is back together. I have got here the AGNUS out of my Amiga 500. Pin 1 is that end. Okay, that's in. Let's hook the mains up. Right, mains power is going on. Okay, we've got nothing. A20 is out of the way. Nothing. Okay, it helps if I plug all the leads in. Right, so now let's try again. Power on at the mains. We get front panel display. So let's press the power on button and see what happens. Green light is flashing, but still we've got nothing. So we've kind of proved that it's not that. I mean, that's a positive thing. We've actually proved something. We know that the AGNUS is not where the problem is. What we don't know is where the problem is. And I think it could be one of these other buffer chips, but you know, we are prodding at straws, as it were. Okay, now I take that back. Let's have a look at the DENISE chip and work our way down. We saw what was here before. It was just like 1 volt and absolutely nothing else. We've still got that 1 volt kind of level, but we are seeing actual signals coming through. And I think occasionally we're getting actual full values. Yeah, there you go. We were definitely not getting that before. Ah, that ain't right. This is the clock. I think this is the green signal. We actually have something there, so maybe we're getting a green screen or something, but it's not coming through to the video. So that is very positive. That is actual video signal, and we can look on the other side here. I think we should be seeing the red signals, and we are. Good. I think that's actually positive. Now we need to follow through. I guess it's going through these. They don't feel particularly hot. Going to the hybrid. And the hybrid, I think, is basically the voltage dividers and output drivers. So I need to go and look at the circuit diagram. We don't have the DENISE circuit diagram. We have to having to go from the Amiga 500 one, because for some reason they haven't put the video output circuit in the DENISE in the CDTV schematics. Everything else, but not that. And that is what we want. Ho hum. So I did this off camera, but I checked down the signals here. We saw that on the scope. They go to the video hybrid, which is this big chunky black thing here, but they go through these HC245s. So I had a look on these HC245s. They go in this side and out that side, and I followed all the signals were on there, and all the signals came out there. So these 245s are fine. That then goes into the video hybrid, and it comes out of the video hybrid and it goes to the video connector. So I probed the back of the video connector. I don't know what the pinout is of this, but I just went along this row here, and we have definitely got video signals on this connector. So I conclude that the video chain is working, or at least partially working, in the sense that we are getting stuff coming through and going out. We've got sync pulses, we've got everything. It goes out, but it does not appear on the monitor. So my next thought was maybe it is the machine set to NTSC rather than PAL, because my monitor probably won't display NTSC. So I checked the schematics, and there is a jumper called JP11. According to the schematic, JP11 should be open for PAL and closed for NTSC. And you can see it there. It's connected to AGNUS pin something, and it goes to ground. And that is most definitely open. So it should be set to PAL, but it does not seem to be. So I've plugged in the RS232 port, and we are going to, DiagROM is in. We are going to look at the serial output. Hopefully OBS is going to record this. So let's power it on and see what happens. That is definitely giving us diagnostics. So this is a vast improvement. We've got diagnostics coming out of the serial port. So the machine is running. We know the CPU is running. We know that the machine is basically going. We have no keyboard or anything attached, so we can't do anything else with that. But nothing on the screen. Here is my Amiga 500. It currently does not work properly. It's not booting. It was giving a yellow screen. This is the problem that happens when you use your own kit in order to try and fix somebody else's kit, and you end up killing your own kit. Right, I'm not going to diagnose this at the moment. It's a yellow screen generally, which means either the AGNUS or CPU or something. It does keep trying to reboot, and sometimes it just goes off. So I've got a cheat sheet that's showing me all the pinout of the video port. So I'm going to go from this end and start with VSync. There we go, that is 5 milliseconds, so 5, 10, 15, 20, that's fine. It's 50 Hertz. That's our HSync. Oh, it's gone yellow. Yeah, okay, that's fine. This is our CSYNC, and you can see that the 50 Hertz is overlaid on the thingy stuff. Right, then we go to the digital ones. That's digital R, digital G, digital B, digital I, then the analog, sorry, there we go. So that is about 0.7 volts. Let's turn it up. That's blue, that's green, that's red. The other two on the back here are inputs from Genlock, and we don't need to worry about those. So that's what we get on a at least working video output, even if the machine itself is not working. So we can reference that back to the CDTV and see what the difference is. CDTV, same situation as usual. We have nothing coming out on the monitor. Okay, I will look at the scope. Let's turn it down to 1 volt, and we'll go from the same end and see what we're getting. So VSync, 50 Hertz, exactly the same. HSync, CSYNC, that's where we're getting nothing. Got H and V but no C. Okay, right. Digital red, digital green, digital blue. I'm betting that it's the CSYNC that is stopping the monitor. Then let's go from the other end, because I always lose count. That should be red analog. That should be green analog. That should be blue analog. We've got nothing there. That's interesting. Does that mean we have a problem with the hybrid? That's interesting. We've got no CSYNC and we've got no analog RGB. Okay, let's go away and think about that. Now, looking at these HC245s, I can't tell you exactly which signal is which, because they appear to be in a different order to the A500, and it's only the A500 schematic that is available to us. So, however, I've determined that This one covers the red and the green signals. This one covers the blue and the sync. And one of these 4 pins at this end is the CSYNC. So we're going to have a look at the input pins, starting from here, and we're just looking for signals. So 1, 2, that looks like composite sync. 3, that also looks a bit like composite sync. 4. Right, so those are the various syncy type, clock type signals. And we can look on the output of this chip. And okay, pin 18. So that is, I'm going to guess that's the dot clock. 2, 3, 4. Okay, so we're getting the signals coming through that chip out the other side, and I believe that the CSYNC comes straight out of that chip and onto here through one of these resistors. So we're looking at a problem with the resistor. I don't know which of those resistor packs it is. I'm going to guess it's that one, but I can't be sure. And a connection problem between there and there and there. And unfortunately that means we're going to have to take this board off again. Now, I've been working under a bit of a misapprehension, specifically that this video circuit, which I'll remind you we don't have a schematic for, that this video circuit works kind of like an Amiga 500, in that we've got the video hybrid, and that comes from DENISE through these buffers and then goes out to the video connector. But in fact it's not true. It works actually a lot more like an Amiga 600. And here we've got the schematic for an Amiga 600 video circuit. And what this does is it goes from DENISE through the equivalent of the video hybrid, which is actually on the Amiga 600 board, into a CXA 1145 PAL NTSC encoder, and that then goes out to the modulator and the RGB signals. So the output is actually buffered and doesn't come directly from the hybrid, but it's buffered through this chip. And where is this chip, you might ask? Well, actually it's on this. This is the antenna TV composite video output plug-in card that plugs into this socket here on the underneath, kind of like that. And this has on it the CXA 1145 encoder chip. And these signals here on this connector take the video in and also pass back video out. And this is why I couldn't figure out that this hybrid didn't go to this connector but disappeared off down here. And similarly, these connections disappear off down here. The reason is because they're going through this card. So we should be able to see, and this card goes in this way up. It's single-sided, so the pin connections are actually all on this side. But we should be able to see on here the video signal coming out of the hybrid and going into this, and then coming back out of this and going to that. We're not seeing that happen, so that suggests either we don't have a very good contact here, in which case we can just clean the contacts and hopefully that will sort it out. Or we've got a problem with this encoder chip. But either way, we've actually got something to go on. So I'm going to clean the contacts of that, plug it all back in. Unfortunately, we need to plug it all back in again. Won't it be funny if we've done all this digging and prodding and poking around and stuff, and the answer turned out to be clean the contacts? Now, I've given that a good clean with some IPA, and you can see from the pad that it's pretty dirty. And that's now a lot cleaner than it was. I've also squirted the connector underneath with contact cleaner. This can go in, and it goes this way up in the track. Now, one thing that we can measure, and I've scrawled a rough circuit of what is actually going on inside as far as the pinout is concerned and as far as the connector is concerned. There we go, that's the actual pinout of the video slot. So I'm hoping that that's actually a good connection. So we've got pin 2 there, and this is pin 2, so it's actually like that. So we've got ground, red in, red out, green in, green out, blue in, blue out, composite sync in, composite sync out. Now we should be able to see that those two are connected together, because on the PCB they clearly are, and that will give an indication that it's plugged in. So what were we? Red in, red out, green in, green out, blue in, blue out, sync in, sync out. Yes, they are connected together. Is it going to do anything? There we are. See, something. Not for very long, but there was definitely something there. So I'm going to prod the connector now. So let's work our way along. This is red in. Okay, we're on 500 millivolts. We've got a signal there. Red out, we've got nothing. Green in, we've got a signal there. Green out, we've got nothing. Blue in, we've got a signal there. Blue out, we've got nothing. CSYNC, we've still got nothing. That's audio right, that's audio left, we don't expect to see anything there. That's digital ground. This is the CDTV pass-through button. Goes high or low according to the front panel. This should be 3.58 megahertz. There we are, yes it is, 3.58 megahertz. And that is VCC. There we are, we've got video going in, but we've got nothing coming out. And we don't have CSYNC, which is interesting. Okay, with some poking around, I've determined that the CSYNC signal comes from this 74HC244 via one of these resistor packs, and the resistor pack is 47 ohms, so we can measure between here and here. I've highlighted them just to make them easier to find, and we should see 47 ohms, 46.5, so 46.8. So if we've got a signal on there, we can trace it back to coming in on the other side, and then hopefully we shall see what we shall see. Because I'm starting to think the reason we're not getting video out from here is because we're not getting CSYNC in. And probably this 1145 chip is driven by the CSYNC signal. Just a guess. Right, chip is not in, or the card is not in at the moment. I'm not worried about that. I just want to see what this CSYNC signal is doing. I'm just looking for the CSYNC line. So that's CSYNC coming out. Okay. Ah. Well, it was there. Or something was there. Let's power it again. Nothing there now, so let's look on the input side. 1, 2, 3. 4. Something flickered and died. Or something briefly flickered and went away. So we need to find CSYNC elsewhere on the board and see what it's doing. So I've marked these out on the chip just to make it easier to find. What we need to do is work out why CSYNC, which comes from pin 80 on AGNUS, we can look at pin 80 on AGNUS. And there we see our CSYNC signal. And goes to this pin here, except it doesn't, and this pin here, except it doesn't. So why is it not getting from there to down there? That is the question. And is it the connector, or is it on the PCB? We're going to have to take the board off again and bleep it out and see what's going on. Okay, so I've taken the AGNUS socket off, and we can beep it on the board from here to here. So it's definitely fine there. Now the AGNUS is in this socket, and you can see quite possibly, hopefully, where is it there? That's not the CSYNC signal, but it's definitely a pin that was not going in the right hole. So I think we have a connectivity problem with the socket, and I can beep through from the top pin to the connection underneath. So that's our problem. I'm going to try a different socket. I've got some different kinds of sockets. Now these are cheapies from AliExpress. They may well not be any good, but we can have a look. If we find a good one, that might be a good one. We might be able to get it in, and it makes good contact. I have to ask, is this the Bodge wire from hell? I spent the entire of Saturday building this. It's basically a breakout for the DENISE so that I can poke the contacts, because I figured out why we're not seeing the CSYNC signal, and the answer is both simple and annoying. I have spent so much time pushing my oscilloscope probe onto that pin 82, that it has moved the contact, and it now no longer makes proper contact with the socket, and as a result it no longer comes out onto the main board. And it kind of took that entire thing to do it. And you can see, I mean, it's a soldering wire mess. Well, it's not really a mess, it's all very organized, but it's a thing unto itself. the creature. So shall we see if it actually makes a difference? So far I've measured that CSYNC comes out onto here, but I haven't gone any further with it. So I'm going to put this bit of paper underneath here because I don't want anything on the back of that accidentally shorting out on the board. And I've jammed the leg of a resistor, actually it's the leg of a capacitor, into that hole so it does make contact from the pin to the socket. Now the socket is never going to get used again after that, so that's not a problem, and that's my Agnus out of my Amiga 500, so I'm not too worried about that. I can live with it. Video card is plugged into the back, that's plugged into there. I'm going to turn on the monitor and we're going to look at the CSYNC signal first. I've made a big diagram of the Agnus PLCC, I'll turn it the way around so that you can read it. PLCC socket, looking down on it so I can know on there what is actually going on. Normally they would show you it from underneath. So I still don't have the ribbon cables plugged in, so we're not going to get a display on the front panel. I'm not worried about that for the time being. Right, so we should look at this top line. Right, so this first pin here is A16. That's the address bus. A18. That's the address bus. That is the V-Sync. That is H-Sync. And this, whoops, is C-Sync. And we can see that is definitely happening. So we can go and have a look on this HC245, and there we can see it's happening. So we can reasonably predict that it's going to come out of the port. So let us have a look at the screen and see what happens. 3, 2, 1. Ah! We have video. So it's going through its initial startup colours. That's checking memory and so on. And this is where it should be writing the menu. Okay, I guess this is the point at which it's crashed. But that is, I believe, progress. Okay, I've beeped out all the connections on the Agnus and they all go to where they should go on the CPU, Gary, Paula, the logic to the RAM and so on. I'm a bit suspicious of the RAM connections, DRD 1 through 15, because they seem to come out quite often as being sort of undefined. And while there's occasionally some signals on there, that's what basically comes from the RAM. So we could have a problem with the RAM. We could have a problem with the kit. I don't think these 244s, the F244s, are the problem. They seem to be passing signals okay. But what we get, there we go, what we get is basically a yellow screen, and it's intermittent. It'll go away, it'll blank for a bit, and then it'll come back as if, I guess, it's retrying. And according to the magic list of color codes, a yellow screen means there was an error. It's basically an undefined error that kicked in before the exception handling was up and running on the CPU, and we really don't know what it is. So what I'm going to do is put the DiagROM back in and try it again and see if we get any further and if we get anything on the screen now with that. But I'm sort of happy with this little interface board, breakout board. It does seem to be doing the job. but something is still fundamentally wrong. And at the moment it could be anything. I'm confident in the chips as such, the CPU, the AGNUS, the CIAs, Paula, Denise, Gary, they all work quite happily in the Amiga 500. What we can't test is the RAM, because it's this horrible zip stuff, and I certainly don't have any replacements. I think I have some F244s, but I don't think they are the problem. And I don't just want to go around replacing everything willy-nilly, because that doesn't really teach me anything. Okay, let's put the DiagROM in. Okay, DiagROM is installed. I've got the serial port attached and is capturing on the screen, and we are monitoring the laptop. So let's fire it up and see what happens. Right, we're getting output from the laptop. And we're getting the colour flashes on the screen. Oh, I'm seeing red. I'll have to go back and read that. And then as soon as we get to the menu, then it goes blank. We're not looking at an illegal exception error, illegal instruction error. Let's try that again. Switch it off, switch it on again. It's going to keep going on here. Filling, right, addresses. Oh no, that's address error. Okay. So we're getting lots of address errors. Bus error. Chick inst detected, and now we've turned to panic, system halted, not enough resources to generate a better dump. Okay, let's go away and dissect that and see what we are getting, or what is possibly the cause of it. Now, as far as I can see, the problem is basically reading and writing chip RAM, this stuff, when sometimes it doesn't get back what it writes. And we've seen that from the serial bus output, serial port output. It's writing address data into the memory, and what it reads back is not the same as it reads in. So it looks like it's 16-bit addresses seem to be okay. It's the 32-bit addresses that are going wrong, which could be the UDS and LDS signals, which is what the CPU uses to distinguish between a 16-bit word and a 32-bit word. So it has to do it in two parts, because this is only 16-bit wide memory. So I kind of don't know what the problem is. It's either going to be the sort of LDS, UDS signals, which are down here on the AGNUS, or it's going to be the data bus signals, which are up here on the AGNUS. And I've measured them on the scope. They all seem to be, as far as I can tell, okay. Leastways, none of them is stuck. They all do what they seem to be sensible things. But obviously this doesn't think so. And if we have a regular kickstart in there, then it yellow screens. So that doesn't think so either. So we've got a number of possible suspects. Maybe the memory is wrong. I'm not entirely convinced about that, because the lower 16 bits work fine and it all comes out of the same chips. Maybe the buffer logic is dodgy. These 74F244s are the address decoding for the RAM, and we just need to look at other buffers that link to these buses. So the main address bus and the main data bus, as far as AGNUS is concerned. So we've got this candidate here. This talks to these SRAMs. So I'm going to pull this one and socket it, and that way we can run it outside of the system and we can isolate these static RAMs and eliminate them if nothing else. Okay, here we go. Unit is plugged in. These are not attached, so there's no front panel display, but that is socketed and nothing in it. Power to the switch. We've got our usual flashing lights. No, we've still got the address errors. So what are our options at the moment? Well, in terms of buffers that directly go onto the chip bus, I think I've actually swapped them all out. I mean, it's basically those ones and those ones. Now, it could be the memory itself. It could be timing because of the length of these cables. I don't think it's any of the actual chipset because they work fine in my A500. So I'm kind of at a loss. I think next time I'm going to build up the replacement 2 meg Agnus board. Partly because I want my Agnus back. Because I can't use my Amiga, my own Amiga with that in here. And also, if that is the memory that's the problem, then by switching it out and using the onboard memory on the 2 meg card, then that is going to basically cut that out of the circuit. And so it could work with that in, just doesn't work with that not in. And we can probably live with that. Although I would like to know what the problem is. But honestly, right now, I don't have a clue. Okay, that's a wrap for this time. Please check out my Patreon if you want to support the channel. Like and subscribe and hit the boost button if you have that available to you. It's all going to help the channel. And I'll see you next time. See ya. Bye.